So once again, welcome to Dr. GV lecture series. I am Dr. Yuvaraj, Assistant Professor, Mechanical Department. So with continuation with the previous session, I am going to speak about the D'Alembert's principle. So generally, this principle states that the sum of the differences between the forces which has been acting on the system and the time derivatives of the moment of the system itself, along with my virtual displacement consistent, which can either by constraint of the system is 0, or else in simple words it can able to say the inertia force on the torque and the external force on the torque which has acting on the body together, and it can results in the static equilibrium. So that is how this D'Alembert principle has framed this kind of has defined the principle in that way. So based upon this dynamic analysis, based upon the D'Alembert's principle, based upon the Newton's law, we have to solve the dynamic analysis of the 4-bar mechanism. So since we having a 4-bar mechanism and there are so many mechanisms are there, we just need to start with the 4-bar mechanisms. So if we speaking about the 4-bar mechanism, we have to speak either dynamic analysis of reciprocating engine, and we have to do the inertia force and the torque analysis by neglecting the weight of connecting rod, and third about with respect to the velocity and the acceleration of the piston, and the fourth about angular velocity and the angular acceleration of the connecting rod, and the fifth one force and the torque analysis in the reciprocating engine by neglecting the weight of connecting rod, and the fifth it is about the equivalent dynamical system, and the sixth it is about the determination of two masses of the equivalent dynamical system. So based upon these 5 different portions, we can able to categorize the topic with respect to the analysis. So let me begin with dynamic analysis of 4-bar mechanism and as well as the slider crank mechanism. So in this image you may see the 4-bar mechanism. Here you having a 4 link. The first one it is an fixer link, following that input, following that coupler, following that it is an output link, where the input link and the output link both are having the rotary motion. In terms of coupler, it is a coupler which act between the connection between the input link and as well as the output link, and it can making the rotation in that way. Okay, but the moment of the motion which can happen only in these 4 different kind of motions. The first one it is about the inner dead center, and the second one it is about the outer dead center, and the third one it is about the distance between the displacement. So based upon that we can able to make it. Okay, so this dynamic analysis of the 4-bar and the slider crank mechanism we just categorize with respect to their D'Alembert's principle. So for any engine force analysis we have to consider the first and very beginning first law. It is about the Newton's first law. So what do you mean by Newton's first law? Newton's first law states that the object continue its state of rest or continue in state of motion unless if it is acted upon by some external force. Either the force can begins the movement, or either the force can stops the movement of mechanism. So based upon these 2 different axes, or based upon these 2 different position of the object, that forces has been categorized. So according to the second law, if you are considering the force analysis on a mechanism, so in that second law of motion it was clearly stated. What it was stated means when the object has been making a movement, or the acceleration of the movement of the particular object, it can totally depends upon with respect to the weight of the object. If the weight of the object is very high, the acceleration according to the weight it can be calculated. Suppose if the object has moved fastly by giving a small acceleration, it is totally depends upon the mass of the object. So the mass can be the key component with respect to the acceleration. The acceleration is totally dependent on the mass. If the mass is very high, the acceleration also is very less. If the mass is very less, the acceleration is little bit high. It is totally based on the weight of the object or weight of the vehicle. Okay, based upon that the Newton's second law has been framed. Okay, so this is what it was stated, F is equal to ma, where F is nothing but it is a applying force, and m is nothing but it is the mass, and a is nothing but it is the acceleration. Okay, so based upon that we can able to do the calculation. Thank you.